In many physical problems that are important in chemical engineering, which cannot be completely solved by theoretical or mathematical methods, can be handled by dimensional analysis. That means in many cases, or I can say in many problems of chemical engineering, it is very difficult to solve that problem by theoretical or mathematical methods. But at that same time, that problems can be easily solved by using dimensional analysis. What is that dimensional analysis? Dimensional analysis is a method of correlating number of variables into a single equation. I am repeating again, dimensional analysis is a method of correlating number of variables into a single equation that forms a dimensionless group. So, what we have to do in this dimensional analysis? We are trying to correlate the variables into a single equation such that that equation makes dimensionless quantity or dimensionless group. That is known as dimensional analysis. Dimensional analysis has two methods. That means this dimensional analysis of correlating the number of variables into one group, which makes a dimensionless group, that can be done by two ways, or that can be done by using two methods, Rayleigh method and Buckingham's pi theorem. These are the two methods which are used in chemical engineering problems to solve this dimensional analysis. We will see these both methods in today's session. So let us start with the first method, which is Rayleigh method. Here I have taken a problem statement, and that problem we will solve by using this Rayleigh method. So I have taken here one problem. This is the statement of a problem. The power required P for an agitator depends on propeller diameter D, rotational speed of an agitator N, liquid density ρ, viscosity mu, and gravitational acceleration G. Find by dimensional analysis the correct representation for power requirement in terms of dimensionless group. So in this problem, it is given that the power required for agitator P depends on these quantities: diameter, speed, liquid density, viscosity, and gravitational acceleration G. Now what we have to do by using this Rayleigh method, we have to come up with a relation between power and these variables in the form of dimensionless group. By using this method, let us see how. See, power is a function of, or I can say power depends on diameter D, rotational speed and this viscosity mu, density ρ and acceleration G. Fine. So power P is equals to K. What I have done? These variables. Now power P is dependent variable and it depends on these variables D and ρ, mu and G. So D and ρ, mu and G are independent variables and power is dependent. So I have given a exponent to all independent variables. See, I have written D raised to A, N raised to B, ρ raised to C, mu raised to D and G raised to E. I have given exponent to independent variables. So this is my equation number 1. Write the dimensions of all the variables in terms of m, l, theta. You all know very well how to write a dimension that you are right now studying in your subject, material and energy balance, computations, right? So how we can write the dimensions of all these variables: power, diameter, rotational speed, density, viscosity and acceleration due to gravity G. So these are the dimensions. You all know how to write the dimension. Fine. Power dimension is m1, l2, theta minus 3. Diameter dimension is l1. Speed dimension is theta minus 1. Viscosity dimension is m1 L minus 1 theta minus 1. Density dimension is m1 L minus 3 and gravitational acceleration dimension is L1 theta minus 2. So these are the dimensions. So in equation number 1, now in place of variable I am putting dimension. See, equation 1 can be written as, I can write like this. I am just putting variable, in that I am putting in place of variable I am putting dimension. So here you can see, this is the power dimension, this K as it is, this is diameter dimension raised to A. I have already given the exponent. So in place of variable I am putting dimension. So I can write like this. So this is my equation number 2. Now equating the exponents of ml theta. See, when I am equating the exponents of ml theta and I am writing right hand side and left hand side. So when you compare the exponents of m, so right hand side exponent of m is 1. So 1 is equal to c plus d. Left hand side exponent of m is c and d. So 1 is equals to c plus d. This is my equation number 3. Exponent of L, 2 is equals to a minus 3c minus d plus e. I am doing just the comparison of exponents of left hand side and right hand side, nothing else. So don't be confused. See carefully. Exponent of L is 2 is equals to a minus 3c minus d plus e. This is my equation number 4. Exponent of theta, minus 3 is equals to minus b minus 3 minus 2e. This is my equation number 5. So these are the exponents comparison. Now there are 3 equations in 5 unknowns. So it is difficult to solve. So what we do? We are expressing the exponents a, b, c in terms of d and e. Understood? These are the 3 equations and 5 unknowns. So it is difficult to solve. Therefore, we are converting or we are expressing the exponent a, b, c in terms of d and e. How we can do it? From equation 3, I can write c is equals to 1 minus d. From equation 5, b is equals to, what will happen? Minus 3 plus d plus 2e. Fine. Or b comes on this side. So b is equals to 3 plus d plus 2e. So again c is in terms of d, b in terms of d and e. And from equation 4, put c is equals to 1 minus d here. Put b is equals to b value here. So when you solve, you get a is equals to 5 minus 2d minus e. So now I have converted a, b and c in terms of d and e by using 3 equations, 3, 4 and 5. Fine. Substituting the value of a, b, c in terms of d and e in equation number 1. So what will happen? See, p is equals to k, d raised to a. So now what is a? 5 minus 2d minus e, n raised to b. What is b? 3 minus d minus 2e. Rho raised to c. What is c? 1 minus d. U raised to d as it is, d raised to e as it is. So now all these variable exponents are in terms of d and e only. Now what we have to do? Combine d exponents and combine e exponents. Again I am repeating. Now the next step is to combine d exponent variables and to combine e exponent variables. So what will happen? Collecting the terms into groups having same exponents, we get, see, p by d raised to 5 n cube rho is equals to k. These are the variables having d exponents and these are the variables having e exponents. See, these are the d exponent variable, these are e exponent variable and these are constants. So p by d raised to 5 n cube rho is equals to k d square n rho by mu raised to minus v g by n square d raised to e. These all the 3 groups, this group 1, this group 2 and this group 3. 3 groups are dimensionless group. When you put the units of this, all the units will be cancelled out. That means these three groups are dimensionless groups. So our equation number 1 is our required relationship. Right? So this is the Rayleigh method, and by using this method we can come up with a dimensionless group. Now let us see second method, Buckingham's pi theorem. This is the statement of a problem. Pressure drop due to friction for the flow of a fluid through a pipe depends on the diameter of pipe B, length of pipe L, velocity of fluid U, density of fluid ρ, viscosity of fluid mu. Obtain the relationship between pressure drop delta P and given variables using Buckingham's pi theorem. Delta P pressure drop depends on these variables. So we have to come up with a relation that represent the relation between pressure drop and these variables and in the form of dimensionless group. For solution, the relationship between the variables affecting the pressure drop for the flow of fluid in a pipe may be written as function of delta P d L U rho mu is equals to 0. This is my equation number 1. In equation 1, there are 6 variables, delta P, d, L, U, rho and mu. So 6 variables and 3 fundamental dimensions. How I can say 3 fundamental dimensions? Because when you write the dimension of all these variables, you have only 3 dimensions, m, L and theta, mass, length and time. That means 3 dimensions. Here there are 6 variables and 3 dimensions. Buckingham pi theorem states that the number of dimensionless groups forms is equals to number of variable minus number of fundamental quantities. Here number of variables are 6 and fundamental dimensions are 3. So at the end of the method, you will come up with a 3-dimensionless group. And you know it in advance by using this method. Number of dimensionless groups formed is equals to number of variables minus number of fundamental quantities. In this case, 6 minus 3. That means 3 number of dimensionless groups will form. See how? In this method, we have to form recurring set. Now, what are these recurring set and how they form? The recurring set must contain 3 variables that cannot be themselves form dimensionless group. You have to select the variables such a way that that variables do not form a dimensionless group. See, L and D cannot be selected as recurring set because they themselves form into dimensionless group. L by D, meter and meter, that means it forms a dimensionless group. So L and D we cannot select as a recurring set. Delta P, rho and U cannot be selected as recurring set because they also form dimensionless group. How? Delta P upon rho U square is a dimensionless group. So we cannot select it in a recurring set. Delta P is affected variable. In recurring set, the affected variable which is delta P is also not selected. So other than that, now what we can select as recurring set? We select D, U and rho as recurring set because they themselves not form a dimensionless group, and D and rho and U are not affected variable, dependent variable. So D, U and rho are selected as a recurring set, and dimension of that D dimension L, U dimension L1 theta minus 1 and rho dimension is M1 L minus 1. So these are the dimension of recurring set. Now what we have to do? Now here, this is important step. Here I am converting the variable in terms of dimension. See, each of the dimension M, L, theta can be written in terms of variable D, U, rho. Fine. So L is equals to D, M is equal to rho D cube and theta is equals to D, U minus 1. Don't be confused. I am just converting the dimension in terms of variable. So I have a form of M, L, theta in terms of variable. L is D, M is rho 1 D cube and theta is D1 U minus 1. From this, Now three-dimensional groups are formed by taking each of the remaining variables. Recurring set variables other than that variables remained are delta P, L and U. And we make three-dimensional group from these variables. Delta P, L and mu. How? Taking delta P dimension is m1 L minus 1 theta minus 2. Fine. So what will happen? Delta P m minus 1 L1 theta 2. So put m equal to rho dq, L equal to d and theta equal to d u minus 1. Put here. So what will happen? See. Our first dimensionless group will be pi 1. Name of the first dimensionless group pi 1 is equals to delta P, here rho d cube raised to minus 1, d du minus 1 raised to 2. So combining these, you will get the form delta P by rho u square. So this is my first dimensionless group. If you put the units of all these variables, all the units will be cancelled out. So delta P by rho u square is my first dimensionless group. Taking L as dimension, L. So L comes here. So L, small l is variable and capital L is my dimension. So L minus 1. So putting here pi 2, L d raised to minus 1. So L by d is my second dimension. And similarly for mu has dimension m1 L minus 1 theta minus 1. So mu into m minus 1 L1 t1. Putting data in form of variables, mu rho d cube raised to minus 1, d raised to 1 and d u minus 1. So by combining you get the form mu upon d u rho. When you put the units, it is dimensionless. So this is my third group. So these are my three-dimensionless groups. So now these three-dimensional groups can be written as delta P by rho square is function of L by D and du rho by mu. This is my equation number A and this is the required relations. So by this way, we can solve the dimensional analysis by using Buckingham pi theorem method. So this is all about dimensional analysis. We have seen both the methods, Rayleigh method and Buckingham pi theorem. I hope this is clear to all. Thank you.